Hello and welcome to a series of 4 videos on 4-note chords. In this video, I will be laying out a way to systematically categorize all 4-note chords. I want to preface this video with some of the primary ideas to think about with respect to 4-note chords. So first, that there are 43 different or prime 4-note combinations based on the 12 tones of the chromatic scale. I'll be laying out how this is realized, but also to make things a little bit easier, I have included a document which is linked in the description of all of the different 43 prime 4-note combinations. The individual notes in the chord are not as important as the intervals or the distance between the notes, and root notes are not always bass notes. In fact, there can be chords that you play where roots don't appear in the chord at all. The same chord structure can function in different ways depending on the context. In other words, what comes before the chord and what comes after the chord. And a 4-note chord does not necessarily infer 4-part harmony. In other words, minor 7th, major 7th, or dominant 7th. Because a 4-note chord can imply 5-part harmony. For example, a 9th chord, or 6 or 7-part harmony, an 11th chord and 13th chords respectively. If you're playing in a band, a bass player or keyboard player can play part of the harmony, and if you were a guitar player, you could play a 3 or 4-note chord that implies a much larger harmonic structure. So you always have to take that into account. It just turns out that 4-note chords yield a tremendous opportunity to explore some different colors and some different kind of harmonic textures, especially if you're playing in a band. Playing really large, dense chords can sometimes muddy up an arrangement. So using 3 and 4-note chords can really be helpful and useful, especially in trying to develop some different harmonic language. Now, in order to kind of talk about harmonic structures, sometimes it's really useful to talk about set theory. I'm going to be using some of the terminology that Alan Forte introduced in the structure of atonal music. However, this is mostly going to apply to tonal ideas at the end of the day. Just talking about this language can be really useful, and I hope to kind of demonstrate how that can be useful. So in previous videos on harmonic transformations, I looked at this diagram here showing different intervals and how you can express those. And in the bottom row, we see one way that you can express intervals is just by using hexadecimal notation or numbers with A and B standing in for 10 and 11. So let's go back and review this idea that there are 43 different or prime 4-note combinations based on the 12 tones of the chromatic scale. So about 30 years ago, I sat down to try to figure out by hand all of the different permutations of scales and different combinations. And I could have saved myself a lot of time and not reinvented the wheel if I had known about some of this theory out there. But needless to say, I learned a lot through this process. So the way that I went about it is to assign a number using hexadecimal notation to each note, and just starting with the first 4 notes. So we have 0, 1, 2, and 3. So that's the first 4-note structure. And then just moving that E flat up to E, or 3 to 4. And so now we have 1 or 0, 1, 2, 4, and 0, 1, 2, 5, and 0, 1, 2, 6, 0, 1, 2, 7, and so on until you have all of the permutations. So quickly, I understood that the individual notes in the chord are not as important as the intervals or distance between the notes in the chordal structure. So let's go back to this original 0, 1, 2, 3 structure, C, D flat, D, and E flat. And if we start to look at how these inversions happen, we can take the note C and put it in the treble or the soprano, and we get D flat, D, E flat, and C. But if we state that from 0 being C, we get 0, 1, 2, B. And so these are the same structures, just from a different note name. So this 0, 1, 2, B is the same harmonic structure. It's just transposed to a different note. So it turns out that this 0, 1, 2, B is the first inversion of 0, 1, 2, 3. We can do this process again, taking D flat, putting it up to the soprano, and then we have 0, 1, A, B, or D, E flat, C, D flat. Again, we can look at 0 as a C, and we can see that this is transposed, so it's the same structure. And so now we have the second inversion of 0, 1, 2, 3, which turns out to be 0, 1, A, B. Doing this process again, same process, we now have E flat, C, D flat, and D, or 0, 9, A, and B. And again, we can look at 0 from C, see that's the same structure, just transposed. And so now we have the third inversion of 0, 1, 2, 3. So now if we break each one of these down, we see that all of these different inversions have the same interval makeup. So we have 0, 1, AB has a half step between the first and second pitches, and then 4.5 steps, and then a half step and a half step. So we then have the next permutation, 4.5 steps, and then a half step, half step, half step. So we have 3 half steps, the same as we have up top, as well as that 4.5 steps. If we look at the other inversions, we see that the same interval structures are there, the same distance in between each of these pitches. So we quickly realize that it's not necessarily about what the pitches are individually, but their relationship to each other that designates these different structures. So if we look at this 0, 1, 2, 3 structure, it turns out that we're going to call that 4-1 using Forte numbers, or Alan Forte's system of designating these structures. This is called a pitch class. But again, if you're too caught up with the verbiage or the names of these things, you can always toss these out. This is just one way that you can start to sort through and organize all of these different structures. So you see right here that we have 0, 1, 2, 3, 0, 1, 2, B, 0, 1, AB, and 0, 9, AB. These are all related. They're all inversions of each other. And so as we'll see later, looking at 0 as a root is actually just a matter of convenience, not a matter of function. So we're using root here and using 0 just to simplify some of the usage of categorizing these structures, not talking about any kind of functional relationship. So the next structure turns out to be 4-2, and this is 0, 1, 2, 4. And we can see that all of these different inversions have different relationships in terms of their interval distances than 4-1. The next one is 4-2B, and this is sometimes confusing to some people because they see, well, why don't you just call it 4-3? Well, the B relationships, as you can see if you download this document, you can see that there are a number of pitch classes that don't have a B relationship and some that do. Turns out that B relationships are about negative harmony. Now, there's a lot of videos out there and a lot of literature you can read about negative harmony. I really suggest that you go and avail yourself of looking at some of those videos. I'm not going to replicate a lot of that here, but I just want to show you really quickly what these negative relationships are and the relationship between 4-2 and 4-2B. So let's look at both of these side by side. So 4-2 has an interval structure of half step, whole step, and then 4 steps. So if we look at this backwards, negative basically just means that it is a kind of retrograde, or it's backwards, or it's upside down. Another way to look at this, it's negative reflection. So whereas 4-2 starts by going up a half step, if you look at this interval structure backwards, in other words, you start from the 4, and instead of going down, you go up. So if you can see how both of these are mirror reflections of each other. There are useful ways of kind of looking at the B relation and the negative relationship of these different structures. It can be useful if that's what you want to start to employ. So instead of calling it 4-2 and 4-3, calling it 4-2b makes that negative reflection or negative relationship obvious, so you can start to explore, okay, so what is that negative structure? And instead of trying to figure it out, it's already there laid out for you. The negative structure of 4-2 is 4-2b. So any B relationship is going to automatically be the negative of whatever whatever pitch class set it is. So next we have this notion that you don't necessarily have the same root or a single root in any pitch class structure. So if we look at 4-26, that is the set 4-26, we see that one of these interval structures is a 0-3-7-A, or a root minor third, perfect fifth, minor seventh, which is a minor seventh chord. But one of the inversions of that is also a C6 chord, or 0-4-7-9. So is 4-26 a minor seventh chord, or is it a sixth chord? Well, the answer is yes, it's both. It depends on how you use it, how you implement it. And in forthcoming videos, I will be addressing the different ways that we can explore voicings of these different structures, and then talk about how they relate to scales and how we can create chord scales from these 4-part structures, and also talk about voice leading in these 4-part structures. So thank you so much for listening. If you have any questions or comments, please leave it below, and I hope you get something useful out of this. Thanks again.